Hi, just a quick review on interpreting graphical characteristics today. I know that you covered all of them, but we're going to put them all together here just to make sure you've got it. And I think you do. First, let's just remind ourselves about what it is we're talking about when we say what are the graphical characteristics. So for instance, when we talk about domain, we're talking about all, let's use a smaller font. Hold on. Not a smaller font, but a smaller, thinner line. So all possible x values. That's what we're talking about when we say domain. And range would then be all possible y values. Least value. And we can have relative and absolute, right? Relative or absolute. Absolute means that there's absolutely no other point lower or that has lower value for the y value than the one we're talking about. Relative means that none of the other points around it have a y value as low. And the maximum, same thing. The greatest value, let's write greatest, not most, greatest y value. And again, we can have either relative or absolute maximum. Relative means that the point is higher than any of the other points are immediately around it. Absolute means there's nothing else on the graph with a higher y value. Increasing and decreasing, we both want to be able to indicate where a function is growing, and we look at the y value, but we express for both of these the location in terms of x. Whoops, in terms of x. Zeros, essentially we're talking about x-intercepts, the points where the graph intersects with the x-axis. Continuity, we want to identify where or what interval, on what interval there is continuity. So we want to know about the interval in terms of x. And in behavior, we want to know about as x goes to negative infinity, what's happening with the y value. And as x goes to positive infinity, in other words, the right-hand side, what's happening to f of x. Okay, so now let's look at an example. For this function that's right here, exhibited right here for you, what I want you to do is I want you to pause the video and I want you to try to answer the questions that are on the right-hand side, the graphical characteristics. So pause the video, and then when you're ready, start the play again and check to see if you've got the right answers. I am going to go ahead and put the right answers in, but I want you to try before you do this. So this kind of gives you a little bit of review. So here we have the domain for this function goes from -5 to 5 inclusive. And the range for this function goes from -4 to 4 inclusive. We have an absolute min at, looks like it's about -2.5, -4. And looks like we have an absolute max on the other side there at +2.5, 4, +4. Okay, so this function has occurring, it increases in a couple of intervals, but the interval that I'm interested in right here I'm sorry, as it increases, it decreases, then increases, then decreases again. So when I'm looking at increasing, I am looking right, that's fine. I am looking at this section right in here. So it seems to me that this function is increasing from negative 2.5 to positive 2.5. On the other hand, it's decreasing. Let's change colors. That's fine. It's decreasing over here and over here. So it's decreasing from negative 5 to negative 2.5. And then it is also decreasing from, oops, 2.5 to 5. I see a couple of zeros here. I see a 0 at negative 5, 0, at 0, 0, and at 5, 0. The function is continuous from negative 5 to 5. And for the end behavior, I'm going to just put this over here so I have a little bit more room to write. As x goes to negative infinity, there is nothing going on. F of x does not exist. Right? Because this ends right there. And as x goes to positive infinity, f of x does not exist. This is just one piece of another function. This function is made up of just one part, and it kind of ends between, it only exists between negative 5 and 5, so it really is no end behavior. Let's look at another one. Here we have, yes, an absolute value function. And again, pause and try to answer these questions, and then I will do the same right here. Okay, so the domain here is all reals. The range is y is going to be greater than or equal to 0. The minimum value is 0, 0. And that is absolute min. And there is no max. This function is increasing from 0 to infinity. It is decreasing from negative infinity to 0. And it has 1, 0, and that 0 is at the point 0, 0, the origin. It is continuous throughout, so it is continuous from negative infinity to infinity. And I'm going to put the end behavior over here again. As x goes to negative infinity, f of x goes to infinity. And as x goes to positive infinity, f of x again goes to infinity. And let's do one more. Alright, so looking at this function, your domain, notice that this circle is kind of filled in there, right? It's not open, it's not empty. So on this one, your domain is x is greater than or equal to 0, and your range is y is greater than or equal to 0. Your minimum value is absolute, and it is at 0, 0. There is no max, again. It is increasing throughout the function, so it is increasing from 0 to infinity. It's never decreasing, so that we can't even answer that on this one. There is 1, 0, and that's the point 0, 0, which is right there at the origin. And it is continuous on the interval from 0 to infinity over the entire domain. And finally, let's put the end behavior over here again. As x goes to negative infinity, f of x does not exist. And as x goes to infinity, f of x goes to infinity. All right, I hope having these couple of examples offered you a little bit of a review. Study hard.